everybody, happy Earth Day. Welcome to Wednesday, April 22nd. This is actually the 50th anniversary of Earth Day. So make sure today you go do something that helps the planet. Recycle, clean up some litter, just enjoy nature. And today we're going to get into our lesson on planning investigations. So AKS 6D is to plan and carry out an investigation on how a change in the environment can affect a population, an organism, and the ecosystem. So let's look at an experiment real quick to do a little bit of review. So this is baking soda and vinegar. Some of you have done this before. So we've got some baking soda, we've got some vinegar, and we've got some food coloring. So we add the vinegar, the food coloring, there's the baking soda, and we get a chemical reaction. All right, so keep that in mind of what happened and what our ingredients were for the next part here. All right, so we have two students that replicated a similar experiment. So I want you to take a look at the two students' experiments. All right, I want you to look at what they have set up. So they have four different volcanoes. All right, and so they're testing what's going to make the best explosion. Okay, so I want you to look for some things that you notice, and then which one do you think is better, the better experiment, and why do you think it's better? All right, so hopefully you noticed that in experiment 1, we had vinegar, different amounts, and then switched to lemon juice, different amounts. Okay, they're both acids. Then we had 5 grams of baking soda, then 1 gram, then 2.5 grams, then 8 grams, so that changed. And the amount of red dye changed. Whereas in student 2, we have vinegar all the way through, and we change it by a half a cup each time. And then we keep the same amount of baking soda and we keep the same amount of red food dye. Okay, so our better experiment is experiment 2 because we will know if, let's say, this last volcano makes the biggest reaction, we know it's because of the more vinegar. Okay, but over here, if we, let's say we have this one with the lemon juice and this one with the vinegar, both have about the same reaction. We don't know if it's because of lemon juice, because this one has more baking soda, because this one has more dye. We don't know why a certain explosion or reaction would be bigger or smaller because they've changed everything. Okay, but here we've only changed one thing, so we know exactly why. If all of these stay the same, then we know that vinegar doesn't have anything to do with changing the reaction. If each one gets a little bit bigger, then we know the more vinegar, the better the reaction. If each one got a little bit smaller, then we would know too much vinegar doesn't make a good reaction. Okay, so you should only be changing one thing. So let's look at that a little bit more. When you plan an investigation, you first start with observations, things that you notice, that you measure, that you see. You make a question based on your observation that's testable, and then you make a hypothesis, which is a prediction of what you think is going to happen based on your observations. Okay, and then you also have to have some controls. You have to keep things the same throughout your experiment so that you know if something changed, it changed due to that one thing that you altered. And the one thing that you alter or change is the independent variable. That's the thing you're testing. In our last experiment, it was the amount of vinegar. And then the dependent variable is the result. What happens because of your change? So if you change the amount of vinegar and the reaction gets bigger, then we know what happened and why. And then lastly, you should be collecting data during your experiment. So in this experiment, maybe you could collect the amount of foam produced or the height of the reaction or the length of time that the bubbles are produced. Then you look at your data, you look for trends, you calculate averages, you make a graph. Depending on what kind of data you have, you figure out which way to analyze that works best for your data, and then you make a conclusion. Was your hypothesis correct? Are you able to answer your question? Do you have a new question now? All of that goes in your conclusion. So if we look back to our experiment here, our question was, what is going to make the best volcano? Okay, and remember, we're looking at experiment 2 because that was the best one. The controls are baking soda, amount of baking soda is a control, amount of red dye is a control, and type of acid is a control, because we stuck with vinegar the whole time. We didn't switch it over like this one that wasn't any good. Okay, our independent variable, that's the thing we changed, and that would be the amount of vinegar. We changed the amount of vinegar. The dependent variable is the size of the reaction, or the length of time of the reaction, depending on how you want to measure it. And your data, again, would be how much foam was created. Maybe you're calculating the volume of foam. Maybe you're just timing how long it worked, how high up it went, depending on how you set this up. All right, so you are going to get an actual experiment that happened, or an actual problem that happened in an ecosystem. And we're going to look at some observations of that problem, and we're going to design an experiment around it. So here's observation 1, observation 2, and observation 3. So you should be thinking of a question. What is going on? So what can we investigate? All right, so you should have observed, look at all these extra legs, extra little leg nub on these frogs. And you're probably wondering what's going on. Okay, so these frogs were actually found by middle school students in the 90s in Minnesota. Okay, they found a whole bunch of frogs with extra legs or missing legs or extra eyes. And the researchers were wondering what is going on, how are these being caused? Okay, this happened in one county in Minnesota, but then the next year they found over 2/3 of Minnesota counties were finding frogs like this. So there's definitely something going on. Scientists know that when we see an increase in deformities, that could be a sign that something's wrong, because frogs are absorbing a lot of things through their skin. So the health of the frog is closely linked to the health of an environment. So amphibians are typically the first organisms impacted by changes to an ecosystem. And so if we're talking about an ecosystem, we have a food web that frogs are a part of. So if we start having a sharp decline in frogs, because these deformed frogs, they can't get away from predators, they can't swim well, they can't find food, so they're going to be a decline in their population. So how would that affect an ecosystem? So think about an ecosystem. Imagine a food web in your head with frogs in it. And if our population goes way down, you should be thinking that anything that eats a frog is also going to go down. And then the things that frogs eat will go up, because there won't be frogs to eat them. And then this will cause little ripple effects in the whole ecosystem. Eventually, all the organisms will be impacted in some way. Okay, so what's doing this? So there's 3 main things that could do this. So pollution could be causing these deformities, all right, because they're absorbing things through their skin. A parasite, there's a parasite that could be burrowing into the tadpole during development, which could be causing some of these deformities, or it could be the amount of ultraviolet light that the frogs are exposed to during development. So those are the 3 possibilities. You're going to be designing an experiment choosing one of those things. Okay, so you're going to plan your investigation. So after this video, you're going to go to Google Classroom, and you're going to find this, you're going to find a slideshow just like this. You're going to drag in what you want to do your experiment on. So if you want to know more about pollution, you're going to drag that over here. If you want to do parasites, you're going to drag that over here. Okay, then there's 3 slides following this. You are only going to do one of them. So once you've done your hypothesis, you tell me what your hypothesis is. So if we go back and you're doing UV light, maybe your hypothesis is, if I expose the frogs to more UV light, then the frogs will, and you tell me what happens. They'll have more deformities, they'll have less deformities, whatever you think will happen and why. Okay, so you type your hypothesis in. Now, these slides, you're only doing one. So if I'm doing UV light, I'm not doing this slide. Okay, if I'm doing UV light, I'm not doing this slide. If I'm doing UV light, this is the slide I need to do. So I'm going to drag these over. And you're not going to use all of these. You're setting up your experiment. So you should have something about tadpoles and something about light. Okay, if you're doing pollution, you should have something about tadpoles, something about pollution underneath each of these pictures. Okay, but you're only doing one of these slides. If you're doing parasites again, you're going to drag something about tadpoles, something about parasites. And then the last thing you're going to do is you're going to type in your answers here. And if you don't remember, come back and watch this video again. And then finally, you're going to go to Google Form on Google Classroom, and you're going to answer some questions about planning and investigating scientific investigations.